Recently, I was screwing together a robotic hand, which is a project that I do in my university, and I thought, wouldn't it be great if I had a drill driver to do this for me? But I don't own a drill driver, so instead of buying one, I'm gonna make one from scratch, a better one.
Here's the plan. I'm going to design the drill around this screwdriver. I'm going to make a 3D printed case that is fitted with some sort of high torque motor, and that motor is going to be controlled by some circuitry. The user will be able to press one of two buttons. One will turn the screw one way and the other will do the opposite. This means that I can screw something in and take it out. I'm also going to chuck a current sensor in to get some feedback to auto stop the motor. You.
I'm sorry, little one.
When using the datasheet for the motors to actually dimension the thing, I realized this thing up here, and I'm very happy I did, because that would have meant that I would have had to reprint stuff if it was wrong, and I never need to reprint stuff or waste material. With the 3D printer leveled, I was able to print the main motor case that holds the bigger than normal motor, and the screwdriver case. I also printed a handle that I may have forgot to record anything about, but just imagine there's a clip of that printing too.
What is that? What is that? What is that?
So I got this thing working, but look how messed up this battery is. That is not the on and off switch. Oh, because this battery is so temperamental, I'm going to switch it out for this 9-volt one. I normally wouldn't do this because of current draw in the circuit and powering motors, but because there's only one motor, this is probably okay. So the first thing I did was I regulated my voltage source down to 5 volts. This is a 5-volt linear voltage regulator, and that's because I knew that my motor was 5 volts. And basically what this is it's just a simple button circuit, and all that I'm doing is I'm allowing myself so that when I press this button, I get an output that is high on my Arduino. I've just configured the Arduino to be set up as an input, that pin is an input. Basically what this means is that I can either make my motor turn right or left depending on if I click this button. One of the main bits of this circuit is the TB6612FNG motor driver, and I'm going to get that from the old sound card circuit. I had to transfer that motor driver onto a new breadboard, which was a little bit annoying, but it's what I need to drive the motor, so it is what it is. Before I go any further, I've realized there's a little problem with what's going on here. I've got this screwdriver, which I've developed my entire system around very intelligently, and what the issue is right now is that this screwdriver has become really blunt. So it basically means whenever I want to screw anything in, I have to really press it down. My drill thing obviously is not going to be able to do that. So what I'm going to do is I'm actually going to redesign the front of the drill bit to not take this in, but instead just to take in the tip and then put other little drill bits inside. And that will mean that I can actually customize what screw goes into my thing, which is actually quite cool. AKA, I'm making a better bad drill.
I never need to reprint stuff or waste material.
I redesigned the top of the drill, initially to get this hexagon shape. I guessed the measurement, then just tested it down to the size it needed to be, which definitely didn't involve wasting more material. Now I could properly assemble the case. I didn't actually need any duct tape, so that was a first for me, so that's cool.
So with the drill constructed and code written so that it can turn right and tighten a screw, I'm going to test its functionality on the sound card. Oh, it actually works. Now I've got to do the incredibly hard job of getting the drill to spin the other way so that I can loosen things.
Wow!
So now I can conduct a test, see if the left way works and if the right way works. Well, I know the right way works, but... Yeah! So that's the drill working. I unironically actually used this thing to start constructing the robotic hand that I mentioned earlier in the video. I don't know when I'm going to talk about that project, probably way further down the line, but that's as far as I'm going to go for this. I wanted to add a current sensor, but I've got 2 tests this week and 3 tests next week for uni, so I'm going to go suffer through those instead. Bye.